It all begins with something incredible, a burst. But not in the literal sense. When modern wineries start processing grapes, the first technological focus is to break down the structure of the berries as efficiently as possible. It's not just about crushing the grape, as was done for centuries in the past. Now, technology is used that can burst the cell walls without damaging the seeds, skins, or the juice itself. The grapes are fed into a special crusher. It doesn't just crush the berries, but also separates the stems to prevent unwanted bitterness. But the main trick comes a little later. Pneumatic presses are used, operating with the help of air. They create internal pressure, under which the berries seem to squeeze themselves from the inside out. This not only preserves the flavor, but also allows for much more juice to be extracted with minimal loss of aroma. Modern presses are so sensitive that they can adjust the pressure down to a fraction of a pound per square inch. Everything is controlled by a computer. If the grape variety is delicate, the algorithm can be set to be as gentle as possible. The result? The berries literally burst in a controlled chaos, giving rise to the first stage of the future wine. And all of this takes place in complete sterility. The equipment is treated with steam and ozone. The berries themselves can undergo preliminary disinfection with ultraviolet light. Processing begins literally within a couple of hours after harvesting, in order to preserve the aromas that evaporate as quickly as dew disappears at dawn. And this is only the beginning. After all, true wonders of flavor are born not only from the pulp, the electronic nose. While people continue to marvel at the aromas of wine, machines have already learned how to analyze them. Welcome to the world of electronic noses, sensory devices that replace tasters at the very first stages of production. These devices operate on the principle of gas chromatography, separating aromatic compounds and smelling them at the molecular level. Imagine a device that can, in a second, identify how many complex esters, terpenoids, and other volatile aromas are present in the grapes, those very compounds that create the unforgettable taste of wine. The producer simply inserts a sample of grape juice into the device and within a few minutes receives a complete profile: how fresh the aroma is, whether there are notes of overripeness, how intense the skin's scent is, or if there are any traces of rot. Such analyzers are not only faster and more accurate than humans, but they also store data to compare harvests from year to year. Artificial intelligence can even predict what this grape will turn into after several months of fermentation. This is no longer romance, but cold, precise science. But it is precisely this that guarantees the wine will turn out not just good, but perfect. While machines are busy sniffing, some are tackling a completely different problem: how to stop time. Cold versus time. Harvesting grapes is a race against time. As soon as the berry is cut from the vine, processes begin inside it that can ruin the future flavor. That's why modern wineries use cold as a weapon against time. Immediately after harvesting, the grapes are placed in refrigerated containers. The temperature is just above 32 degrees Fahrenheit. This makes it possible to slow down oxidation and bacterial activity. Some estates cool the berries right in the vineyard using mobile refrigerators or dry ice, but that's not where it ends. Before pressing, the berries may spend several hours in a special cold chamber to stabilize their structure. This is called pre-fermentation maceration, but without actual maceration, only cold and nothing else. Interestingly, at low temperatures, aromas become more pronounced, scent molecules are preserved, and then, during fermentation, they are released in a powerful and pure stream. So cooling is not just about preservation, but also about enhancing the future flavor. This stage only became possible with the development of precise climate control and logistics. In the past, wine would start fermenting even before it reached the vat. Now, time has been stopped. But the most exciting part is ahead, the first encounter with the machine that knows how to extract the very soul from the grapes. The mechanics of juice. If grapes are the heart of wine, then juice is its blood. And today this blood is extracted with milliliter precision. All this is thanks to modern presses, which are controlled by computers and can literally sense when they need to stop. Pneumatic presses are stainless steel capsules with a flexible membrane inside. This membrane inflates with air, gently pressing the berries against the perforated wall. The juice flows out on its own, without crushing the seeds, without bitterness, and without excessive astringency. But the most interesting part is the multiple cycles. The press doesn't just extract the juice once, it does so according to a program, first with gentle pressure, then a pause, then a bit stronger. And this continues until everything possible is extracted without compromising quality. Control systems monitor the juice's density, color, acidity, and even viscosity. The press can stop automatically if the parameters go beyond the ideal range. Everything is automated, and a person is only needed here to supervise. Some wineries use presses with vacuum extraction. The pressure inside the chamber is lowered, and the juice comes out naturally as if boiling. This is an even gentler method, especially for white and rosé wines. This is how, gently and precisely, the liquid is born from which the drink will be made. But for now, it is lifeless. Everything will change when special beings, created by science, are added to it. A genetic army of yeast. At this stage, the wine comes to life. All thanks to yeast, tiny fungi that feed on sugar and produce alcohol. But today, yeast is not just wild cultures from the air. They are true biotechnological soldiers selected and modified to deliver the perfect result. Modern laboratories create yeast strains tailored to specific grape varieties. Want fruity notes? Here are yeasts with enhanced synthesis of complex esters. Need a clean profile? Take a strain with reduced sulfur production. Even the color of the wine can be adjusted with yeast. Some of them stabilize anthocyanins and prevent oxidation. Yeast production is like launching a pharmaceutical product. Everything is sterile in bioreactors with controlled temperature, pH, and oxygen concentration. The result is billions of cells ready to turn grape juice into a living substance. Some wineries go even further. They use hybrid yeasts that combine the properties of different species. There are even strains that can operate under extreme conditions, such as high acidity or alcohol content above 15%. Adding yeast is not just about pouring in some powder. They are activated, tested on samples, and adapted to the environment. Only then does fermentation begin. And it is from this moment that the juice stops being just juice. But what happens next will astonish even the skeptics. Machines that monitor the fermentation process themselves, 24 hours a day. Robots in the cellar. Winemaking cellars used to resemble dark basements filled with wooden barrels and the pungent smell of fermentation. Today, they are almost sterile laboratories where automatic systems and sensors play a key role. The fermentation process is no longer controlled manually. Instead, huge fermentation tanks are equipped with probes that measure temperature, sugar level, pressure, and even alcohol concentration every second. All the data is immediately transmitted to a central server. Algorithms monitor the parameters and, if necessary, adjust the temperature, activate cooling, or initiate mixing. Automation covers even such details as foam removal or tank cleaning. Robots with washing heads rinse the inner surfaces with hot water under pressure without any human involvement. This is not just convenient. It prevents contamination by microorganisms and reduces the risk of product spoilage. Even the mixing of the wort can be done without opening the lid, using pneumatic sensors and rotating stirrers controlled from a panel. Everything operates automatically. Monitoring never stops, not even for a minute. If something goes wrong, the system sends an alarm and the operator can intervene remotely. Modern wineries resemble data centers more than old chateaux. But even these high-tech fortresses still have to solve an age-old problem. So, what exactly is all this fermentation happening in? Steel and glass. For a long time, winemaking was loyal to wood. Oak barrels were considered an essential part of the flavor. But in the 20th century, everything changed. Stainless steel entered the scene. Today, most wineries use it. And it's no coincidence. Stainless steel fermenters have one key advantage: precise control. Temperature, humidity, pressure, everything can be regulated down to the smallest detail. Steel does not let air through, does not react with acids, and does not impart its own flavors. This means that the taste of the wine is shaped solely by the grapes and the yeast. There are also hybrid solutions, steel tanks with elements of glass or polymers. Some even have an inner ceramic lining, which helps preserve certain aromas. And what about oak? It hasn't been forgotten. For wines that require a woody aroma, producers use oak chips or staves, placing them directly inside the steel tanks. The effect is the same, but under control. Modern tanks are equipped with double walls through which a cooling liquid circulates. This allows the fermentation temperature to remain stable regardless of external conditions. And special sensors monitor to ensure that harmful bacteria do not develop inside. The choice between wood and steel is no longer a matter of taste, but a matter of control. And as we've already understood, control is the winemaker's main weapon today. Although sometimes it's not just about controlling, but also about predicting. Wine under control. Today, technology makes it possible to see what is happening inside the wine without even opening the vessel. Next-generation sensors measure density, sugar level, alcohol, temperature, oxygen, and even volatile compounds in real time. This data is sent to analytical platforms which create graphs and predict how the fermentation will develop. If the system detects that the sugar is disappearing too quickly, it could be a sign of overheating. If the temperature isn't rising, it might mean the yeast is inactive, and all of this happens automatically. Moreover, AI systems can now compare the current batch with dozens of previous ones. If the parameters match, it means everything is going according to plan. If there are deviations, the system will suggest intervention, cooling, replacing the yeast, or adding nutrients. The monitoring continues even after fermentation. While the wine is resting, sensors keep measuring the levels of oxygen and carbon dioxide. Even micro movements of the liquid can be detected to prevent stratification. It's like keeping your finger on the wine's pulse 24 hours a day, 7 days a week. The winemaker can sleep soundly. The machine will do everything better and more precisely. But it's not that simple, because after fermentation something extra remains. The disappearance of sediment. After vigorous fermentation, the wine leaves behind something not very appetizing: The sediment consists of dead yeast, grape skins, and tiny particles. If they aren't removed, the taste of the wine will be spoiled. But they also need to be removed carefully so as not to lose the aroma. In the past, everything was done by hand. The wine was decanted, leaving the sediment at the bottom. Today, complex filtration systems are used. One of the most popular methods is microfiltration. These are special membranes with pores smaller than a micron. They let only the liquid through, leaving everything else outside. There are also more innovative approaches, centrifuges that spin the wine at high speed to separate dense particles, or diatomaceous filters, where the wine passes through a layer of crushed silica, leaving all impurities behind. Importantly, these methods do not affect the taste. On the contrary, they keep it pure and clear. Some wineries even use gas filtration. They push the wine through an inert gas which carries away volatile, unwanted compounds. After filtration, the wine becomes bright, clear, and shiny. It is now ready for the next stage, protection. And at this stage, the real battle against microbes begins. A strike against microbes. Although the wine may seem stable, a threat can still be lurking inside. Bacteria and residual yeast can spoil the taste, cause secondary fermentation, or even turn the wine into vinegar. To prevent this, winemakers use a whole arsenal of methods. The first is pasteurization, but not boiling, rather gentle heating to about 120 degrees Fahrenheit. The wine is heated for just a few seconds and then rapidly cooled. This kills most microorganisms without affecting the taste. The second method is ultrasound. High-frequency waves destroy the membranes of bacteria. This method is especially effective for white wines, where purity of flavor is important. The third is ozonation. Ozone is introduced into the container, which destroys microbes and oxidizes unwanted compounds. This method is completely safe and leaves no residue. There are also more precise methods, adding potassium sorbate or sulfur dioxide. But modern wineries strive to minimize additives, relying on physical purification methods. Wine that has undergone such purification becomes stable. It can be stored for years without changing its taste. And only now can we begin to talk about its aroma, the chemistry of aroma. When we say a wine has notes of raspberry and chocolate, we don't mean that anything was added to it. All of this is pure chemistry. Science explains, the aroma of wine is formed from hundreds, sometimes thousands, of volatile compounds, and each of them affects how we perceive its taste. The most important of these are complex esters, terpenes, ketones, and aldehydes. It is precisely these that give wine the scent of tropical fruits, flowers, leather, tobacco, or spices. These compounds do not form by chance. Everything depends on the grape variety, the work of the yeast, the fermentation temperature, and even the material of the vat. For example, terpenes impart aromas of citrus and roses. They are especially active at low temperatures, which is why some winemakers deliberately cool the wine to preserve them. And esters with long carbon chains are responsible for the aromas of pineapple, banana, and vanilla, and only appear during slow, stable fermentation. Nowadays, winemakers can literally control the aromas. Chromatograph analysis makes it possible to determine which compounds are present in excess or in deficiency and to make adjustments accordingly. You can slow down fermentation, change the oxygen level, or even switch the yeast strain right in the middle of the process. What used to be an art has become an exact science. But aroma is not the same as maturity, and maturity is measured by molecules. Molecules of maturity. Wine after fermentation is like a teenager. It is unbalanced, harsh, and loud. To become an adult, it needs time. But exactly how much time, and where is the line when the taste reaches perfection? Once again, science provides the answer. Modern technologies make it possible to track molecules of maturity, compounds that form during oxidation, interaction with oxygen, and the breakdown of wine components. These include, for example, acetaldehyde, lactone, and phenols. It is precisely these that make the taste softer, rounder, and deeper. In the past, the winemaker would simply taste and wait. Now everything is different. Samples are taken regularly and analyzed in the laboratory. There are even express analyzers that provide results in 5 minutes. They measure the level of tannin polymerization, the concentration of phenolic compounds, and the acid balance. Some wineries use active aging. They control the oxygen supply with milliliter precision per week. This allows the processes to be accelerated without losing quality. Special microaerators deliver oxygen in strictly controlled doses, stimulating slow aging just like in an oak barrel. As soon as the indicators fall within the desired range, bottling can begin. But before that happens, it's necessary to determine exactly which bottle the wine will go into. A glass trap. The shape of the bottle is not just about aesthetics, it's an engineering solution, and every change to it affects the taste and shelf life of the wine. The most obvious example is the thickness of the glass. The thicker it is, the slower the changes occur under the influence of light and temperature. This is especially important for white and sparkling wines. That's why champagne is bottled in heavy bottles with thickened bottoms. It can withstand pressure up to 100 pounds per square inch. The shape of the neck affects the flow of oxygen. An elongated neck narrows the passage of air, slowing down oxidation. And wine that is meant to be consumed young is bottled in wide bottles. There, air interacts with the contents more quickly, smoothing out the taste. Even the color of the glass matters. Green and brown glass protect against ultraviolet light. Light is wine's main enemy. It triggers photooxidative reactions that destroy the aroma in just a few weeks. And finally, the material itself. Some producers are switching to biodegradable glass and composites, but for now the classic bottle remains the standard. However, what it will be sealed with has been a subject of debate for centuries. Cork versus screw cap. And so the eternal debate continues, natural cork or screw cap. Some say cork adds charm, while others insist the screw cap is more reliable. But what does science say? Natural cork is the bark of an oak tree with pores that allow air to pass through. This slowly saturates the wine with oxygen, helping it to mature. The problem is that every cork is unique. One cork might be perfect, while another could let in too much air or, worse yet, contaminate the wine with trichloroanisole, a compound that causes a wet cardboard smell. Aluminum caps with a plastic liner provide a completely airtight seal. The wine doesn't breathe, doesn't change, and stays exactly as it was when bottled. This is ideal for young wines that aren't meant to be stored for long, but for aged red wines, this can be a drawback. The solution is modern synthetic corks that regulate the flow of air. They are made with the desired level of porosity, do not absorb moisture, and do not deteriorate. Some producers even add laser markings with a QR code to track the origin. Now each bottle becomes part of a digital story. And this story begins with a single click. Digital control. A modern bottle of wine is not just a beverage. It is an object that is tracked from the moment the vine is planted to the moment you open it. All thanks to digital technologies. Tracking systems are being installed at wineries. Each crate of grapes receives a QR code, which allows you to find out when and where it was harvested, what variety it is, and what the weather was like that day. This data is stored on the blockchain so that it cannot be tampered with. When the wine is bottled, each bottle is assigned a unique code. This code is applied to the label or directly onto the glass with a laser. In the store, you can scan the code and find out who the winemaker was, which vats the wine was fermented in, what yeast was used, and how many days the fermentation lasted. For large shipments, IoT is used. Sensors monitor the temperature and humidity in the containers, as well as movements and impacts. If a bottle is dropped, there will be a record of it. If it has been counterfeited, this will be immediately detected by discrepancies in the system data. In this way, wine becomes not just a beverage, but a part of the digital age. But don't think that control is everything. There is another threat that is almost impossible to notice. Invisible protection. The fight against wine counterfeiting is a real technological race. The more expensive the bottle, the more sophisticated the protection methods. And today, they are almost completely hidden from view. One of the most advanced methods is microcapsules. These are invisible particles that are applied to the label or cap under ultraviolet light. They create a unique light signature. Each batch has its own passport, like a snowflake. Verification is only possible with a special scanner. Next comes laser engraving. It is impossible to erase or counterfeit. The code is applied to the neck or the bottom of the bottle. It is encrypted, and even if someone copies it, the system will immediately detect a mismatch in the batch. Some manufacturers are implementing RFID tags. These tiny chips make it possible to track the bottle in the warehouse, in the container, in the store, if the temperature drops, or if it has been in transit for too long. Everything is recorded and transmitted to the database. Even the composition of the glass can be unique. Trace amounts of rare earth elements are added, and the bottle becomes signed on a molecular level. It is virtually impossible to counterfeit such wine. But even if it is perfectly protected, there is still another crucial stage ahead. It must be delivered intact and unharmed. Smart logistics. Delivering wine is more than just transportation. It's a true logistical performance where every mistake can cost the taste and therefore the reputation. Wine fears three things: light, heat, and shaking. To avoid them, refrigerated containers with smart control systems are used. The temperature inside is maintained at around 55 degrees Fahrenheit. Not higher and not lower. Any deviation is recorded and transmitted to the producer. Some containers are equipped with vibration sensors. If the bottles are shaken for too long, there's a risk of destroying the structure of the tannins. This is especially important for wines that are still maturing in the bottle. One truck on a bad road and the wine loses part of its flavor. Delivery routes are planned taking into account climate zones, traffic jams, and even the phases of the moon. Seriously, some wineries even take gravitational fluctuations into account during transportation. Warehouses have special lighting that doesn't emit ultraviolet, control of carbon dioxide humidity, and even floor vibration monitoring. All of this is to ensure that the bottle reaches the customer exactly as the winemaker intended. But all of this can be in vain if the final stage, bottling, is done incorrectly. Bottling without air. It sounds simple, pour the wine into the bottle. But in reality, this is one of the most critical stages of the entire process. A mistake at this point can undo years of work. The main enemy is oxygen. Even just a few milliliters getting inside the bottle can oxidize compounds and alter the taste. That's why bottling takes place in completely sealed conditions under an atmosphere of inert gas, most often nitrogen or argon. The bottles are pre-rinsed and filled with gas. Only after this is the wine delivered through sterile tubes. The pressure in the system is balanced so that not a single air bubble can get inside. The bottling equipment is not just pumps, but high-precision dispensers. They measure the volume down to tenths of an ounce. Cameras monitor every movement, and sensors check the weight and air tightness. After bottling, there is instant capping and a second injection of gas into the space under the cork to expel any remaining oxygen. The entire process takes fractions of a second, but the longevity and taste of the wine depend on it. Now the bottle is sealed, but before it reaches the customer, it faces a final exam, a check by a million eyes. Quality control after bottling is like the finishing touch in a painting. Everything must be perfect. And this is where machine vision comes into play. High-resolution cameras scan every bottle. They check the fill level, the clarity of the glass, the tightness of the cork, and the integrity of the label. If anything does not match the standard, the bottle is automatically set aside. But even that is not enough. Samples are taken from each batch and sent to the laboratory. There, they once again measure acidity, sugar, alcohol content, residual yeast, and even check for the tiniest gas bubbles under a microscope. Some wineries have implemented AI-based control. Algorithms analyze millions of images, learn to spot anomalies, and predict potential problems before they even arise. Humans also remain part of the system. The final test is the tasting. Trained specialists sample random selections, checking the taste, aroma, and body of the wine. This is the last barrier before it reaches the market. And now, at last, the bottle is packed, protected, and inspected. It has made the entire journey from the vine to your glass. A process that began with sun, water, and earth ends with the quiet click of a screw cap or the gentle pop of a cork. Behind this bottle is not just a drink, it's 200 days of labor, dozens of sensors, robots, chemistry, logistics, and endless attention to detail. Modern winemaking is not just about tradition and taste. It's biotechnology, AI, sensors, microscopes, and mathematics. Everything here is calculated, from the harvest temperature to the amount of gas used during bottling. Every drop has passed through a digital funnel, yet it has preserved the taste of nature. And the most amazing thing is that all of this is for a single sip, for you to open a bottle, inhale its aroma, and experience something more than just wine.